Hi everyone, my name is Tony Record and I'm an AP Calculus teacher at Avon High School in Avon, Indiana, and it is my pleasure to bring you a video here today that's going to outline the detailed scoring summary of the 2022 operational exam ABBC1 problem. You might be familiar with it. It's the problem that discusses the cars lighting up at a toll plaza, a very common type of rate in and rate out problem that is so oftentimes the first question on both the AB and the BC exam. And so hopefully this little scoring summary will get through some of the details of the scoring rubric that you might have had questions about, whether you're a teacher scoring this problem or maybe a student who's trying to score it yourself. So let's take a look at the question. It said from 5 a.m. to 10 a.m., the rate at which vehicles were arriving at a certain toll plaza is given by the A of t equation equal to 450 times the square root of the sine of 0.62t. T is the number of hours after 5 a.m. and A of t is measured in vehicles per hour. Traffic is flowing smoothly at 5 a.m. with no vehicles waiting in line. And so our first question, write but do not evaluate an integral expression that gives the total number of vehicles that arrive at the toll plaza from 6 a.m. t equal 1 to 10 a.m. t equal 5. So I would say that this is a very typical question that would be presented on a rate in and rate out problem. And if we want to take a very quick look at the scoring rubric, the exemplary scoring response worth only 1 point is the fact that the number of vehicles that arrive at the plaza from 6 a.m. to 10 a.m. would be given by the integration of A of t from 1 to 5. Now, a student would not have to write that entire expression. This is not the kind of problem that asks the students to interpret the meaning of this mathematics in context, because that was provided in the question. The student just merely needs to state this definite integral right here to earn that point. Now there's a few scoring notes that we can go over to kind of hit some of the variations that students may have given. So the response must contain a definite integral with the correct lower and upper limits to earn the point. Anything besides the 1 to 5 will not work. Unfortunately, sometimes students used the 6 to 10, but you can see that in the stem of the problem, the writers really tried to dissuade the students from doing that by listing those two t values. Secondly, and it's not super common that a student would do this, but I understand sometimes that the student is so kind of concerned about integrating absolute value of a rate because we know that the integration of the absolute value of velocity is going to give the total distance traveled. Well, in this particular case, if the student were to have placed absolute values around the A of t expression, whether they did it in the notation A of t or they did it with the actual expression 450 times the square root, it's going to be okay. And the reason is because the absolute value of A is the same as A. The function A of t on the interval 1 to 5 is always going to be positive anyway. So no harm, no foul with the absolute value. Now, we always want to address the missing differential. If the dt or the dx was missing, it's okay. It doesn't have a big impact on this particular solution as it does, say, on the same exam on BC number 2. There's a slight possibility that the student could have sacrificed a point by missing this differential in a problem like that. But in this particular case, everything is going to be okay if that dt is missing, or if a student misspelled the t with an x. We always will allow the students to earn the point in cases like that. All right, and then lastly, a response that has a copy error in the expression for A of t is still going to earn that point only in the presence of the definite integral from 1 to 5 of that expression that contained that copy error. Maybe the student, I don't know, instead of 0.62 said 0.52. we understand what their intent was. It was to integrate the rate at which cars were um, arriving at that toll plaza. And so we want to award them with that calculus knowledge that they've presented. And so I think that pretty much takes care of all the different variations that you can have for this 1 point that can be earned in Part A. Now, Part B, the question reads, find the average value of the rate in vehicles per hour at which vehicles arrive at the toll plaza along the same interval, essentially. And so in this particular instance, the skill that we're testing is the student's understanding of how to set up the average value of a function. And that function, of course, would be the rate function that's given. And so we just simply need to see the 1 over 5 minus 1 in front of that same definite integral that we just talked about. Now, this particular problem is going to be worth 2 points because of the fact that there is a setup point that uses the average value formula, and the fact that the student would have to enter that into a calculator. It's complicated enough that we would have to use the calculator to come up with this decimal approximation answer. And that final answer, of course, is always going to have to be presented to 3 decimal places. We'll talk about that here in just a little bit, since this is a discrete kind of problem. And of course, the proclamation down here is never something that's required. That's just a great exemplary answer. Everything that you see up here in this line would be perfectly eligible to earn both points. Now, what about variations of what you see in that top line? Let's look at some of the scoring notes here. First of all, the use of the average value formula, indicating that A is 1 and B is 5, can be presented in a single or in a multiple step to earn to earn that first point. Okay, to earn the first point is what that should say. So what do I mean by that? Well, let's say that we have a response that integrates the A of t from 1 to 5, okay? And that value turns out to be a little bit more than 1,502 vehicles. Well, the student then would go on to alter that answer to our correct response. Well, we look at that and we know that the way that they got from one response to the other was to divide by 4. It's not explicitly written, but we're going to understand that that was the student's intention. And we're going to go ahead and award both points for a response such as that. So that's an example of it being presented in like a single sort of invisible step that we don't quite see on paper. Now, a response that presents a correct integral along with the correct average value, but let's say it provides incorrect, or let's say at the very worst, incomplete communication, is only going to earn one of those 2 points. So what do we mean by that? Let's say a student sets up that definite integral, A of t, from 1 to 5, and they resolve it using the calculator to get that 1,500 number. But then they set that equal to our answer of 375. Well, obviously that has problems. No, it's a shame because we understand that the student had good intentions and they knew to divide this definite integral by 4. It's just that they didn't communicate that very well. And at the reading, we call this a linkage error. And it's pretty clear that it's a fairly egregious thing that the student is actually equating 2 numbers equal that are certainly not equal. So we're going to go ahead and award them the first point, that they're using the average value formula. But let's say that the final answer isn't quite communicated as well as it should have been. All right. And then, of course, our answer must be correct to 3 decimal places. Well, if a student were to resolve that integral and have that 375.536, but then all of a sudden they decided that they wanted to go ahead and round it, we're only going to award the first point. The answer point would be sacrificed. And I know that this is sometimes a point of contention with both students and teachers, but the best thing that you can do, as a student and as a teacher explaining to your students, is if the problem does not say to round, we have no business rounding, even if it doesn't quite make sense. But a lot of times in the real world, when you find the average of something, it's always going to run the risk of providing a kind of a decimal answer that doesn't quite make a lot of sense. Like 2.5 people on average were in the store at any given moment. That does make sense in the real world. And so we don't want to invent our own rules here. So let's stay away from rounding to an integer value unless the problem specifically asks for it. And then degree mode, something we certainly need to discuss because this problem does contain a trigonometric function sine. So a response that represents answers obtained by using a calculator in degree mode will not earn the first point that it would have otherwise earned. That response is generally going to be eligible for all subsequent points, unless an answer is not possible with degree mode or the question might be made simpler by using degree mode. And I'm going to talk about that very instance here later on in this problem. Basically, at the reading, we call this an inoculation. If a student doesn't earn that very first point because they presented this problem answer in a degree mode, subsequent answers that are still in degree mode that are correct will earn the point, and I will share those answers with you as we move through this presentation. Now, for this particular problem, that degree mode that we're thinking about is 79.416. So that's pretty much a dead giveaway. As soon as you see that, it's likely that the student was in degree mode throughout all of the problem. Right. Another great tip as teachers and students, make sure that calculator is always in radian mode, pretty much throughout your course, but certainly for the AP Calculus exam. And then finally, we do have a special case for this problem. Apparently, during the pre-reading, this was showing up a lot in 2022. And this is a situation where the student just carelessly took the division of 1 over 5 minus 1 incorrectly and got 1/5 instead of 1/4. Now that would lead to an answer of 300.429 or 430 or 43, which is pretty close to our answer, but it's not our correct answer. But we're going to go ahead and rather than deny the students both of the points, it's clear that they knew the process or the structure, I should say, of the average value of a function. And so we're going to go ahead and give them that first point, but they're not going to earn that answer point with that 1/5. That's the only special case, right? Any other 1 over 3, 1 over 6 would sacrifice both points. Moving on to part C. The question asks, is the rate at which vehicles arrive at the toll plaza at 6 a.m., once again, is time 1, increasing or decreasing? And we have to give a reason for our answer. So in this particular case, the exemplary response would show that the derivative of the function a evaluated at 1 is this 148.947 decimal value. And that particular answer would earn the first point. It's not only is it considering a prime of 1, it went on to evaluate it. Now the explanation is that since a prime of 1 is positive, the rate at which the vehicles arrive at the plaza is increasing. Now the student wouldn't have to use such eloquent language as the rate at which vehicles arrive. A lot of times they just might say the word increasing, and that would be enough for us. We don't necessarily like it as teachers. It doesn't kind of convey the wonderful meaning, but again, we're not talking about the AP language exam here. We're talking about a math exam where the student just needs to present their findings in a way that's consistent with the mathematics that they've done. So let's take a look at some of the scoring notes here. The response does not have to present the value of a prime of 1. So if you don't see the 148 number on their paper, it's okay. Now the second line of the model solution above that you see would earn both points. And so without any kind of reference to the value of a prime of 1, just simply saying a prime of 1 being positive means the rate increases is going to earn both of those points. Now, what if a student evaluates A prime of 1 but does so incorrectly? Well, we're going to go ahead and award the first point because the student definitely knew that A prime of 1 was the focus in answering this question. Now, whatever happened that they got that value incorrectly, maybe they pushed some buttons wrong or what have you, that would certainly, you know, jeopardize the subsequent parts of the problem. But even if they have an A prime of 1 that is positive but incorrect outside of being in degree form, we're going to go ahead and not award that second point, right? Even though they might have gotten lucky that their incorrect A prime of 1 was still positive. Now, without referencing t equal 1, the first point can still be earned with any of the following kinds of statements. Let's say the student just immediately writes the number 148.947, accurate to the number of decimals presented. Or if they presented that with no decimals all the way up to 3 decimals. So that would be 149, 148, maybe 148.9, 0.95, 0.94. What we're going to do here is we're going to look at that and say, well, we see that that particular value came from the calculation of the derivative of A evaluated at 1. And so we're going to go ahead and award that first point. Now, I know a lot of people are like, well, wait a minute, that seems very inconsistent. We're now going to let the students earn credit by not presenting a decimal to 3 places. Well, the philosophy is that this is not a value that's specifically being requested. It's just a value that they're going to find and use to answer the question that we've asked. And so very consistently on the AP exam, that is when a student could get by without rounding to 3 places. Now, as a teacher in my classroom, I don't throw that out in front of my students, and I really want them to round to minimally 3 places all the time. But I want you to know that that would be acceptable in this particular problem to earn that first point. And then A prime of t equivalent to 148.947. If that by itself was presented, we're going to go ahead and award the first point. Now, it's not great communication because you can see that the A prime value is not specifically evaluated at 1, but we understand that the intention was there, the calculation was correct. Again, we don't like it as teachers in our classroom, but we feel like on the AP exam, that's not egregious enough to sacrifice the student earning that first point. All right, and then furthermore, in order to be eligible for the second point, the first point must be earned. So when you score this, especially at the reading, when you're scoring so many of these problems, it's always very easy if you don't have that first point earned or in the bank for the student, then you really don't have to worry about what the student wrote for their reasoning. Now, to earn the second point, there must be a reference to t equal 1. So we definitely need to see the A prime of 1, maybe the 148. They can't just simply say A prime of t is positive because obviously that's not true all the time. And then the degree mode answer, as we talked about earlier for this particular problem, is the 23.404. Now, that turns out to be positive, of course, which is good. And so that could lead them to still have the correct answer with reason. And if they've already sacrificed the point in a previous part an A, I believe, for this question, it's going to be okay, and they can still award both. They can still earn both points for this part. Now, in the rare instance that the student was in radian mode before, then all of a sudden switched to degree mode, and then this is the first time that you see a degree mode answer. This would be the first instance that you would not allow the student to earn the point, and then they're inoculated for degree mode answers from this point forward. All right, hopefully that takes care of the part C that has a little bit of, like I said, variation with some of the things that the students could do. Now for the final part, D, it says a line forms whenever A of t is greater than or equal to 400. The number of vehicles in line at time t for a less than or equal to t less than or equal to 4 is given by this n of t function defined by an interval, a of x minus 400 with respect to x evaluated from a up to t. A is the time when the line first begins to form. To the nearest whole number, find the greatest number of vehicles in line at the toll plaza in the time interval a to 4 and justify your answer. So if you've been keeping track, there's quite a few points still left for this particular part. We've got 4 points still on the table here. And so there is the exemplary response. Notice that first of all, in finding a maximum value, we're going to take the derivative of our function, and our function would be n of t. And then we use one of the versions of the fundamental theorem to get the a of t minus 400. Now, as soon as the student recognizes that that derivative has to be set equal to 0, they have the first point earned, even if they don't evaluate it or solve it correctly or even attempt to solve it. Now, from that point to earn the second is the student would actually have to use their calculator and find the values of t at which the a of t minus 400 is 0 or a of t is equal to 400. And a lot of times this might be a very beginning entry point for this problem. We're going to talk about that here in a little bit. It's perfectly fine. Lots of points can still be earned if the student first writes a of t equal to 400. So these are the two decimal values the student would get for those t's, and we're going to provide a point for the students if they found both of those. Now, this is a particular problem that adheres more so towards the candidates test. It's more of an extreme value theorem problem because we are finding the maximum on a closed interval. Now, if you're thinking, well, what about students that try to circumvent the candidates test and use this more as like a localized extrema argument? There is a way that the student could earn credit for that, and we're going to talk about that later. But by and large, this is going to be, in my opinion, the easiest way to earn the point is by setting up this table of values. And we would use the A and the B that we found, our two critical values. And of course, we have to use the right endpoint of 4 in this case. Now, in this particular instance, the n of t is the function defined by this integral, and we ended up with those values if we correctly use the calculator. It might be worth taking note that the left endpoint, a, doubles as one of our critical values because a is the time when the line first begins to form. And so once the student assembles the table, they will have to somehow draw attention to their maximum value, and that maximum value, the greatest number of vehicles to the nearest whole number, would actually be 71. Now, this is an instance where we've actually told the students that they can round. Don't worry if students elect not to round, no harm can be done. And so we'll talk about how the student could still earn credit for a non-rounded answer. So that's what the 4 points look like as an exemplary response. Let's go ahead and take a look at some of the scoring notes. First of all, it's not necessary to indicate that A of t is equal to 400 to earn the first point. Although, as I said before, that statement alone is pretty powerful in light of that first point, and therefore the student would earn the first point. Now, if a student were to say A of t is greater than 400 or equal to 400, when t lies between those two values, that's going to earn the first 2 points. Although it doesn't specifically denote the values kind of individually as an A and a B, we can certainly understand that those are going to be the endpoints of that interval, and thus the student would probably know to use those particular values. But nonetheless, those 2 points are certainly earned with that kind of response. Now, if a student were to say A of t is greater than or equal to 400, along with the presence of exactly one of those two numbers above, that is going to earn the student the first point. but not the second point. We basically need to see both of those to get that second point. And a response of A of t greater than or equal to 400 all by itself, that will earn neither of those first 2 points. You know, the statement A of t equal to 400 is a little bit more, I guess, valuable with that first point rather than the inequality, because the inequality obviously is going to address so many more numbers in that span that we're a little bit bothered by that. But if the student resolved that inequality as a compound equality like you see here, we can still be sort of favoring on the student's side for that second point, but not with just the inequality by itself. A couple of more scoring notes here. To earn the second point, the value for A and B must be accurate to the number of decimal places presented, with at least 1 and up to 3 decimal places. And so this is another one of those instances where intermediate decimal values don't necessarily have to have the 3 decimal place representation. But obviously, the more accurate they are, the better our final answer is going to be in the long run. And a lot of times we like to tell our students to round to maybe 1 decimal place more, 4 places in the middle of a problem, or to use all of the decimal places that your calculator will present, which is typically 6 if we use default settings. And so that's the thing that you want to look for here for that A and B. They have to have at least 1 and at least up to the 3 decimal places. Anything beyond 3 we're going to ignore anyway. And those values can appear either in a candidates table. They could appear as limits of an integral. Let's say when the student's actually going through the process of finding n of t, or they could actually appear on a number line. And once we see them, we're going to go ahead and award that second point. A response with incorrect notation that involves t or x is perfectly okay here. We say this often on the AP exam. If you can't tell a t from an x, just tilt your head a little bit as the readers are reading. So it's okay if the student poorly communicated the t and called it an x. That's eligible to earn all 4 points. Now, as far as those second 2 points of Part D, in order to earn the third point, a response must present the greatest number of vehicles. So we have to draw attention to that. And so this point is going to be earned for answers of 71 or 71.254. Any decimal points beyond is going to be ignored. Now, I know that seems a very contradictory here. If the student rounds, that's great. We want them to round. We ask them to round to the nearest whole number. However, if the student is not going to round, they must adhere to the normal applied rule for decimal presentation, and that would be to at least those 3 decimal places. And so we're looking for that answer point. Now, a correct justification earns the 4th point, even if the 3rd point is not earned because of said decimal presentation error. We don't want that to take them out of 2 of the 4 points for this part. Now, if the student uses the candidates test, the response must include the values for n of A, n of B, and n of 4. All 3 of those must be present in the table to earn the 4th point. And moreover, all 3 of those values must be correct to the number of decimals presented with up to 3 decimal places. Anything beyond, again, we're going to ignore. All right. Now, correctly rounded integer values are going to be acceptable because that is what we'd asked for. So in other words, if a student were to have, let's say, miscalculated the value for t equal 4 and has this incorrect, that's going to certainly lead them to the correct answer. But if this particular value is not correct, then they're going to sacrifice the answer point for this particular problem. We're still going to give them the justification point, but we don't know, this error could have potentially caused that 71 to not have been the largest value. And so we've got to be very careful for that. All the values in the table must be correct. Alternate solution for the third and fourth points. Sometimes this happens. I will tell you, a student really has to jump through a lot of hoops if they decide to use more of a local argument for this maximum than a global, as the candidates test suggests. So the student would have to communicate the fact that the A of t function is greater than or equal to 400 along the interval a to b. And afterwards, from b on up to 4, that A of t function is negative. Well, that is some pretty valuable ammunition here, because what that means is that the n of t value is certainly going to be its greatest at that t value of b, okay, that b value that we've found. Therefore, if the student were to use that b value in that definite interval and get our correct answer, 71.254 or 71, that's going to be acceptable. But you can see that the student has to communicate that on the interval a to b, A of t was positive, and then from b to 4, A of t was negative. Then they would be in the game to earn the points for the justification without referring to a candidate's test. In my experience, I've often find that students might not be quite as thorough with this explanation, and therefore may sacrifice the justification point. And so, again, only my opinion as a teacher is to use, and a reader for quite some time, is to have your students use the candidates test. It's just going to be a little bit safer, in my opinion. And then degree mode, once again, the response is only going to be eligible to earn the first point. And the reason is because in degree mode, our A of t never has a chance to change signs or even be positive at all. A of t is always less than 400 whenever we are in, I guess I should say A of t can be positive, but A of t is always going to be below that 400 in this case. So what that would mean is the student would only get that first point because that's an easier version of the problem. It made it too simple. As always, I would like to share the scoring statistics for this particular problem. AB test for those students, 3.22 is, a little bit on the low side out of 9, especially for a rate in and rate out problem. But nonetheless, that was where that particular problem fell. And obviously the BC kids tend to do a little bit better, as they were a little bit more than 4 3/4 for this particular question. So I hope the video certainly helps you with a little bit of the scoring nuances for ABBC1 for the 2022 exam. And whether you're a student or a teacher, you can always look back through the video to take a little bit more careful look at the relationship between the actual rubric and the work that the student did. Anyway, we'll see you at the next video. Take care.